Okay, so just want to confirm, can you see my screen?
Yes, we can.
Okay, great. Okay, well, let me dive in. And so my goal is to tell you a little bit about step functions. I'm going to start with an overview and then dive in deeper. So I was informed that maybe about most of you probably have not used step functions before. Hopefully most of you are aware of it. We're really trying to kind of raise awareness of the service. And my goal here today is just kind of give you an overview of step functions, kind of like dive in deeper, and then do a little bit of a demo at the end, and then take your questions. And so Sam is here to kind of help out at the same time. So I've been with AWS for about a year now. Before that, I was also, like Sam, a customer of AWS. And I previously, before joining AWS, I wasn't a customer of step functions, so it was new to me. It was new to me after I joined, but it was something that I've kind of seen the power of by kind of working with many different customers on different use cases for step functions, and kind of it's part of the application integration suite of products at AWS, and it's obviously serverless, so it kind of fits into that suite of products as well. Okay, so an overview of step functions. So step functions, as I mentioned, it's a serverless workflow service offered by AWS. We're in most regions. And if you were to build a workflow on top of step functions, our standard workflows can last for up to 1 year. One of the beautiful things about step functions is it's one of the very, very few things at Amazon or AWS that you do not pay for. They'll pay more the longer it runs. So step functions can run up to a year at no charge. We charge based on state transitions, which I'll get to into a minute. And so step functions is able to maintain state for you in a serverless environment at no charge. It's built using something called a state machine, and I'll also dive into that more in a minute. A state machine is composed of kind of steps, workflow steps called states. It's written in the Amazon states language. So you can kind of think of this as the workflow assembly language. So there's many different ways of building a state machine. You can code it up in different languages, which we'll get into, but kind of the base language here is Amazon states language. It's coded in JSON. And what you can use step functions for, the main use case is to orchestrate other AWS services. So some things that you can do with step functions just right off the bat. So orchestration, our most common use case is just customers that are looking to use step functions with Lambda, and they build an application on top of Lambda, and they use step functions for orchestration. I'll show you an example in a minute. So you can take Lambda functions, you can turn them into applications, and you can use your step functions-based workflow to kind of wrap around them, perform the error handling, perform the orchestration, and things like that. You can do event-driven data processing. So an event comes in, and so that could be like a change to an S3 bucket or things like that. And you could run a workflow based upon those events. We also are running a lot of ETL based workflows, machine learning based pipelines, and then there's a lot of customers that are using step functions for like human centric workflows, BPM, so business process management type applications. IT automation was the way that a lot of users started using step functions in the first place, but kind of our use case has really broadened out since then. And then, so it's driving everything from really short, fast kind of data processing workflows through to like really long running human-centric workflows. Human-centric workflow could be like it could be driving a insurance application process or some sort of approval process or something like that. The way that you define your step function state machines is so you can define them in the Amazon states language in JSON. We also support the Cloud Developer Kit. So there you can define your state machine in either TypeScript, JavaScript, Python, Java, or C#. And last year, we also launched a data science SDK that allows you to define your workflows to create state machines in Python in a Jupyter Notebook environment. And so that's a really neat experience because basically we've built a number of constructs specific to like SageMaker and EMR and Glue. And within a Jupyter Notebook environment, you can visualize code in Python, visualize your workflow, run your workflow, and do it all within a Jupyter Notebook. This is kind of designed to enable data scientists to automate the work that they're doing, and then facilitate them to give them the ability to pass it on to engineering teams. You can to productionize. You can visualize your workflows, and then you can go into the console and you can monitor your executions and debug your executions when they're running. I just want to go through like a very, very simple example, and let's walk through like a store checkout process. And so let's say that you had 3 Lambda functions, and you had one Lambda function for your store checkout process that would check inventory and place a hold on your product. You had another Lambda function that would interact with the external billing system to bill the customer. And then you had another Lambda function that would kind of drive the shipping of your product. So one thing you could actually do to make this work is you could just take your Lambda functions and you could have daisy chain them together, and you could have one Lambda function invoke the other. But it's actually more powerful if you to wrap this up in a Step Functions state machine and build a workflow around it. So what you could do is you could take Step Functions, you could create a workflow, and you could have Step Functions orchestrate this. So you could chain these Lambda functions together using that workflow. But then let's say that you were using this external billing system, and sometimes there was once in a while there was availability issues, and to make it more robust, you wanted to retry billing the customer 3 times as part of this checkout process. So you could go and you could change your Lambda function, and you could build in that logic into your Lambda function. Or the other thing that you could do is you could basically take your state machine and build a retry around that bill customer state. So you'd build the state machine, you would have a state that would call your Lambda function, and then you could just specify a retryer with an exponential backoff. And what it will do, just with very, very minimal code, it will retry the billing up to 3 times before failing the workflow. Let's say that shipping the product involved a human that would go obviously put the package in a box and ship it out, and then they had a button that they can click either via their smartphone or a kind of a computer application once they had shipped the product. Well, you can implement that as well using Step Functions, using something called the Callback Pattern, which we'll get into, and that makes kind of human interactions very easy. Another thing that you could do is you could implement a try and catch. So if the billing the customer ultimately failed, then what you could do is you could catch that failure very easily using a workflow, remove the hold on the credit card, or sorry, remove the hold on the product, and then kind of exit the workflow. We support 2 workflow types. So there's standard workflows and express workflows. So standard workflows is basically one of the big differences between the two is there's two modes of execution. So you have standard workflows that guarantee once and only once execution, and then you have express workflows that guarantee at least once execution. So how would you use these things? So standard workflows, this is for long-running workflows. They can last for up to a year. They store all of the execution history. They guarantee that if each state will only go through once. So it would be good for things like banking transactions. You can imagine that you wouldn't want to debit or credit an account more than once. And it's very, very robust in terms of like failure recovery. Every single state is checkpointed into a database. And so our standard workflows, this has been around since the start of the service. This is used for things like IT automation, control plane type activities, order processing, kind of machine learning and ETL type applications. Last year, we launched something called Express Workflows, and basically this was based upon customer asks. Customers had asked us for kind of, I want to use step functions more broadly, but it's too expensive for my use case. I have like very fast, very simple use cases, and so this is more like data plane type activity. So we created Express Workflows. The maximum duration on them is 5 minutes. It still uses the Amazon States language to build them. The execution history is sent to CloudWatch logs rather than stored within step functions. It supports all of our service integrations, and this is used for like stream data processing, like IoT data ingestion and things like that. So from an IoT perspective, one way to think about it is you may have a device that gets shipped out to a customer, perhaps by a telco. You could consider using standard workflows to provision that device. It may involve kind of interacting with the customer to configure the device. There's different systems you would need to interact with to provision it. But when that device is up and running in the field, that would be a great candidate now. And you wanted to kind of pull data from it once a day, that would be a great candidate for Express Workflows, where you could pull the device, you could pull down data, you could process it very quickly, and you could do that on a kind of daily or hourly basis using Express Workflows at kind of a fraction of the cost. So workflows are based upon the way that we bill is a little bit differently between the two. So standard workflows is based on state transitions. So steps as you progress through the workflow, each state is charged. Express Workflows is priced similar to Lambda, and it's priced based around kind of memory usage and execution time. These are the service integrations that we support. So the main reason people use step functions is to orchestrate other services. So we support ECS, Fargate, Lambda, and Batch for compute. In terms of ways to kind of integrate together applications, we support SQS, SNS, and step functions invoking itself. From a data science standpoint, we have SageMaker, Glue, and EMR, and this is very helpful for building end-to-end data science and machine learning workflows. We also support DynamoDB, and we just recently added support for code build, so now you can use step functions for your CI/CD processes. For CI/CD. We support multiple ways to trigger a step function state machine execution. So we support API Gateway, Event Bridge, which is the kind of new CloudWatch events, and Lambda. So each of these can be used to trigger a state machine execution. Something we just launched recently, and I'll show you this later on, is the AWS Toolkit for VSCode. We're now integrated with the AWS Toolkit. This is a great place to build up your state machines. So you can either do it in the console. We have an editor there, and or you can now build, visualize, execute your state machines directly from within the AWS Toolkit for VSCode. You can also use SAM in terms of from an infrastructure as code standpoint. You can use SAM, and you can specify a state machine resource in there. It's still using the CloudFormation version of the step function state machine resource, but you can also use CDK. And so you have two ways of building up your state machines. You have your declarative kind of JSONic way of building them in the Amazon States language, or you can use the Cloud Developer Kit and author state machines in the 5 different languages. There's also kind of metrics, logging, and tracing. So we support CloudWatch metrics for things like executions, to monitor the different service integrations and things like that. We support CloudWatch logs. This was launched recently for standard workflows in February. And you can use X-Ray today. So today you cannot trace your state machines using X-ray. This is something that a lot of customers have been asking for. What you can do today is you can trace a lot of the downstream resources from an X-ray standpoint, and yeah, so these are the metrics, logging and tracing. Obviously, very important to give you the visibility into your state machine executions. We also last year launched the Data Science SDK. So I'm not sure how many in the audience are kind of working on data science, ETL, machine learning type applications, but this is a great way to build out your state machines. And it has really nice constructs, as I mentioned already, for SageMaker, Glue, and EMR. We also have customers that are using this who aren't using it for data science applications, but they've just found it as the SDK is a great way to build out the state machines in Python. I'm going to dive into now some application patterns that people are using quite a bit with step functions. So one is error handling. So this is like, I mean, let's say that you have Lambda functions and you want to have a way of handling the errors in and around them. So here's an example of a way that we have some customers using this type of pattern where you would have a user come in, create an account. Perhaps there's a conflict on the account name. You could iterate by suggesting alternate account names until that account is created successfully, and then you could send a welcome email to your customers as part of a state machine execution. This is what the code would look like for one of the states. So you would have the create count a state. You would have a Lambda function called create account, and if there was an error when the account was created, you would specify what your next state is. So you would go to suggest account name. If you receive the error, account already exists error, and you would have another Lambda function that would suggest a new account name, and you would iterate back and forth. Once the account name was successful, then you would go to the send welcome email state. And this could be another Lambda function, or this could be like an SNS, an email driven by SNS, for example. Human interactions. So a lot of people, last year we launched something called the Callback Pattern. And this is a way to interact with external resources. So this could be like on-premise systems. It could be like an EC2 instance that's doing processing for you, or it could be a person. What happens is that when you invoke a service integration, such as Lambda or ECS, it will generate a unique token, and that unique token is passed to the downstream service. And then when using the step functions AWS SDK, if you make a call, I believe it's called send task success, and you pass that token back to step functions, the workflow will continue. And so along with that token, when you pass it back to step functions, you can also provide other data, which you can then bring into your workflow and send and use as part of your workflow. So this is a great way to work with legacy applications as well, and have them driven by a step function state machine. A lot of customers do a lot of things in parallel. So there's two types of parallel states that we support. So first is the parallel state itself, and the other is the dynamic parallelism. So we have a map state, and so this is an example of a workflow that contains both of these types of states. So validate payment. If payment is successful, then you can branch here. Sorry, this is only showing map state. That was a choice state up at the top there, not a parallel state. But yeah, so you would have a choice state that would check the payment, and then basically, let's say that was for a kind of a batch order of payments, you could run map state to iterate through each one of those where you would check availability and for the product and start the delivery process. So one other thing that's important to know about parallel states is that error handling. So if you were to go and you were to put a number of items like states in parallel, the default behavior is if one of those states fails, then it will kill all of the other work that is going on in all of the other states that are going in parallel. And the reason for that is that the assumption is, I mean, if one of the states is unsuccessful, there's no point in continuing on the rest of the work because you're just going to be kind of wasting time and money. There are ways to get around that so that you can actually build, if you build in kind of error handling in, then you can change that default behavior and you can take other types of actions depending on what you want to do. We also support nested child workflows. So step functions can invoke step functions, and so where this is really helpful is let's say you have like really complex state machines, and what you can start to do is you can build up a library of child state machines, and you can include those in those higher level state machines, and start to really kind of simplify your higher level state machine. We have customers nesting up to like 5 levels deep. And we also have customers that are using kind of a standard workflow to kind of nest together a whole bunch of child workflows that are running with express workflows, say doing data processing. And so you could have one thing that you could do, just to give you an example, is you could have your high level state machine, a standard workflow. You could use the map state to dynamically invoke a number of child workflows that were running on express workflows or things like that. It's pretty powerful when you combine together the capabilities of map with nesting. You can also do things like build a Saga pattern where, let's say, a hotel booking system, but something ultimately isn't available as part of the as part of the booking process. Then what you can do is you can roll back all of the bookings that were made previously as part of the workflow. And so we have a number of customers that are using step functions for Saga type patterns. You can schedule and trigger workflows with Amazon EventBridge, and so you can both trigger the workflow and send an event back to Amazon EventBridge upon workflow completion with the success or failure of the workflow. Yeah. Let me just dive into a few more kind of deeper use cases for step functions. So we have a lot of customers using step functions to kind of orchestrate the work that's going on within containers. And one of the nice things about step functions that I haven't really dived into with you yet is the ability to decouple state from functions. And so this is significant because what you can do is you can build like stateless functions, or you can have stateless containers, and they're just responsible for one job, like booking a hotel or billing a customer, and then step functions will maintain state in that workflow. So it will know for each transaction where every single customer is in that workflow, and so that's how a lot of customers use step functions, is to really kind of decouple state from the processing or work that needs to be done. And so here's an example of a customer use case where Frame.io is actually using step functions as it's part of like a media transcoding solution. And in this case, they're actually using step functions for compute arbitration. So part of this workflow, at the start of the workflow, there's an encoder decider, and this encoder decider decides it'll basically analyze the encoding work that or transcoding work that needs to be done, and then based on certain criteria, it will either select Lambda or ECS to run this work. And so you have customers that use step functions for kind of compute arbitration and selecting where a workload will be run, and then wrapping the error handling around it. Another example is using step functions for data science and machine learning workflows. So we have customers such as in Wisdom, they're an AWS partner, and they're using step functions for end-to-end kind of data science workflows for their customers. And so they'll define a workflow in Python within the Jupyter notebook. They'll tie together Glue or EMR with like SageMaker. They'll pull the data, they'll train the model, they'll deploy the model, and then they'll kind of handle failures. And then they will like notify, once the model is deployed, they will notify themselves or the customer of the successful deployment of the model. We also have customers that are using, so when you have like model drift, we have customers that are automatically kicking off a workflow to kind of retrain and run inference on a model when there's a certain amount of drift in that model. And so that's another use case for step functions. We also have a lot of customers that are working to kind of transform that monolithic application into kind of a microservice-based architecture. And so this is something that Yelp did, where they were able to kind of transform a monolithic billing application into a modern microservice-based application. And it was something that they were able to redo gradually, and they also they could shift traffic. Like we have a lot of customers that are kind of like building up solutions on top of step functions and Lambda and API gateway, etc., and gradually shifting traffic over to their new kind of modern cloud application gradually over time. Last but not least, you can use event express workflows to do event handling. And so you could do something like this. So this was a blog that was put together by one of our developer advocates. And in this case, you have a Zendesk ticket filed, which via Amazon Event Bridge through their kind of third-party integrations, an event will come in. It will trigger a step functions workflow, which is going to get the ticket info, going to use Amazon Comprehend to kind of analyze this ticket for sentiment analysis, set some tags, and based upon the sentiment of the ticket, maybe the customer is really angry, and they can detect that. Then they will escalate the priority of the ticket. This happens really fast. Great use case for step functions express workflows. Okay, before we jump into Q&A, I'm just going to hop over and I'm going to show you the step function service, perhaps for another kind of 8 to 10 minutes or so, and then we can dive into questions. So I'll start out in the console and then I'll move over into VS Code. So I'll just show you an example of a state machine that I have in my account right here. So this is the list of state machines within the region that I'm in. This is a state machine that I created previously. I can go in and edit that state machine. This state machine is it's just part of a tutorial that I wrote. That the goal here is to demonstrate a kind of a fan out kind of first to respond fan out pattern. And so imagine that you have something like Uber Eats, and you have a number of drivers that can respond and get a food delivery from a restaurant and deliver it to a home. And so that process would look something like you may want to, or maybe a product that needs to be delivered. So you would check the inventory, check that the food can be available, place a hold on the credit card, request the driver. The driver could have an app running on their phone. The first driver to respond would get the delivery. And so the way that we've implemented this, so the way that I often build out state machines is I start by stubbing everything out. And this is a great way to build it. So you can basically just use like past states and which don't really do anything. You can use pass states and choice states or parallel states or map states to basically stub out your state machine, create the infrastructure for it. And so the first two states here don't do anything. They're just pass states. The way that this is implemented is there's a SNS message that is sent out. I have the drivers. I'm simulating drivers using Lambda functions. So you can have, I only have 2 Lambda functions running right now, but this SNS fanout message will trigger these Lambda functions. They have a random backoff. One of them will kind of raise their hand and accept the delivery, and then if one of them chooses to accept the delivery, then the delivery will be assigned to the driver, and otherwise the customer will be notified of delay. This delivery assigned to driver. So first of all, this request driver state is implemented using a publishing of an SNS message. It specifies the message in here. You'll notice that I'm including the task token. So this is the callback pattern, that unique token that is generated. It's also including the order number. This would be an argument into the workflow. It specifies the topic ARN for the SNS message, and then I also have a catch in here that will notify of a delay. So if there's a delay, it has a 15-second timeout. If one of these Lambda functions does not respond, then it will take a different path and notify the customer of delay. Down here, the delivery is assigned to the driver. This is actually invoking a nested state machine. So I have a very small nested state machine that will do the delivery notifications, notify both the driver and the customer of the delivery. I can just going to go back here, edit, and I can actually run this right now. So I know that this workflow needs me to specify the order number. So execution. And you'll see here, it's shows you in real time the execution of the workflow. I just received a text message notification on my phone. The delivery was assigned to a driver. If we want to know which driver it was, this is where we can go and we can go into the execution history. So one of the nice things about step functions is all of the execution. All of the history is fully tracked, and so what you can do is you can go into see where the execution started. You can see the order number that I specified. This is the role ARN that was used when the ARN that was used when the step function state machine was executed. You can see here the check inventory state. Pass state will just kind of take what is comes into it and pass it on. So you can see the input to the state. You can see the output to the state. It's still passing on this order number. If I get down to the task state, so we get down to the request driver task state. Here you can see the SNS message that is sent out. So this is the tasks token that was generated. You can see that the task is successfully started and submitted. Here you can see that the task success. So a driver in a Lambda function named Alexa picked up the order. So this was the response by one of the Lambda functions when it used the send. When it made the API call to the step function SDK, and then you can, as you go down here, you can see that this is where the delivery notification is scheduled and submitted. If and at the end, we can see that the execution succeeded. So just a very simple example of a state machine. Let me show you the VSCode experience. Okay. So this is the experience within VSCode. If let's say that I wanted to, so one thing that I can do is I can actually, so if you download the AWS Toolkit, you'll end up with a nice little AWS icon on the side over here. You've got the AWS Explorer, and then you have your regions. So I've got 2 regions loaded in here. You got your CloudFormation, Lambda, schemas, and step functions. Within my step functions, what I can do is I can list all of the state machines that are already in my account. I can right-click on any one of these. I can download the definition. I can save the definition in my account. Okay. So now I've got the definition downloaded from my account on AWS, and if I want to visualize it, I can just click on the Visualize button, and here you can see the state machine being visualized. If you want to get started, you can basically create a new state machine. So you can go create a new step function state machine. Here you can select from a number of examples that'll get you started quickly. So I can do select the hello world, and I can visualize the hello world state machine. I can go in and I can add new states onto it. So basically, if I were to go in here and hit Control Space, what I can do is I can select from a series of predefined states, and I could pop in, say, like a new Lambda task state. What it does is it gives me the state, kind of a template for the state right here. And what I would need to do to integrate this in is I would need to basically say that okay, my hello world goes to and true. I could actually do this. Out of order. So I could actually go here, invoke Lambda function, put in quotes, and change my end to true. Change this to next, and invoke Lambda function. Okay, there we go. Did I get that right? Oh, errors detected, and I'm missing a comma right here. There we go. So yeah, so as soon as you get the syntax right, it will update the state machine definition and visualize it. The other thing that I could do is I could actually save this back into my account. So you could either obviously use CloudFormation, or you can publish. We have a fast way to publish to step functions. So quick create. I will. I don't have a good role defined. Actually, I think I do have a role defined here, so I can do the hello world role name hello world name 20th2. So successfully created the state machine in my account. The other thing that I could do is I can actually go over here, and I have my new state machine. I can actually execute it. So this one will take an argument called is hello world example. So I'm going to go over here. I'm going to start an execution, and I will kick it off. Execution is started. Ultimately, this is going to fail because I don't have a valid Lambda ARN in here, but it's always useful to see what a failure looks like. So what I'm going to do is I'm going to go back over to this. I'm going to look for my state machine. So this is actually in US East 1. And we can see here, this is the new state machine I created. It has one, it's been executed once, it failed. If I want to figure out why it failed, I can go in here, I can look at the execution history, and I can see it got to this last state right here. This is where it failed. And I can see, so if I go down here, I can see it's pointing out to me that my ARN is invalid, and it's telling me that it must satisfy the regular expression pattern. So it's basically telling me that I have an invalid ARN. So this basically gives a, so I'm going to open it up for questions now.